Okay, I'm going to start building. So step one is to build the audio section. Here's what the printed circuit board looks like that I got from PCB Way. You got 10 of them for $12 and some change. Shipped the cheap way, and I think it took only a week. First thing I do is I put standoffs on every project, because you do not want to power this thing up sitting on the workbench with clips from component leads lying there shorting things out. Here's what the board looks like head on. One thing that I did is I added an LED and a current limiting resistor here as a power on indicator. Keep me from trying to solder something in when it's powered up or other stupid things. Here's my 13 volt input, 12 to 15 volts, whatever. And here's a reverse polarity protection diode, the one in the D1, one in 4001. Here they are installed. I think I mentioned you're going to buy some 2.5 for male and female headers, because we're going to use these, unless you want to solder your power leads and your power jack onto the board. I don't like doing that, because going and building sections and flipping the board over to solder and etc. The power lead flops around on the desk, and eventually it's going to break off. This is a high intensity bulb. I have a number of these, and the thing with the high intensity bulbs, the case or the critter itself is clear. You don't know what color it is, so you're going to have to get one of these. I recommend these. They're not precise, but they will save you a lot of trouble. They test capacitors, inductors, diodes, LEDs, transistors, and what's interesting, it has this area here for doing SMD components, but it's in a case and I can't get to it. And I'm not doing SMD, so not a problem. First thing you worry about is your power supply. I have these a few of these, and I think I took them out of old computers. But if you don't have this, and I think you can get them for Arduino projects or whatever, those going back to these little 2.54 millimeter, you got male and female. You can take the female strip. I buy them where they're 40 pins. Just cut a 2-pin section and solder 2 wires onto it, connect it to a 2.1 millimeter jack, and it'll be good to go. When I built this thing yesterday, I didn't have my heat shrink handy. It was in a little box and I found it, but I normally put heat shrink over any leads, and if you use the 2.54 millimeter female, the two connections here are going to be exposed. Either put heat shrink on them or use a glue gun and put some kind of insulating material, even nail polish, something to prevent you from causing a disaster. Here I just put the protection diode and the LED with the resistor in, just to make sure that my battery's charged. I'm using a little gel cell. I forgot to take a picture, come back to that. So I'm all set up. Time to go wire the audio amp. And I printed off the schematic, and as I insert components, I will mark them off here, just to, prevent me from leaving a part out, and for checking. You'll see here that I inadvertently picked up the wrong color marker here for R21. I have used different colors so that I can color code each section as I go. Here's what the board looks like, all wired up, and it's good to go. And I used the header here to plug in phones. I'm not going to use headphones because I need to demonstrate to you how this thing is working. And I'm not doing it right now to save time, but I'm going to use powered speaker. And because I'm doing that, I'm going to replace this variable here. I'm not going to use a variable. I'm just going to put a 50K quarter watt resistor here because this is the bias resistor for this first transistor here, Q2. You're going to feed 13 volts in here. There's a 1K here. Then there's 330 and then 50K. So I need this 50K with the 330 to set the voltage on the base. What I do is put a quarter watt resistor in here, and then this coupling capacitor here, C7, I'm going to feed it direct to the base. So that means it's acting like full volume if you had the volume control in there. The way you do this is here's the 3-pin header that would normally be there so I can plug in a volume control. But I just put the 50K quarter watt resistor between the two end pins. This one is ground and this is the high end, and it goes via a trace to the base of Q2. Now, C7 coupling capacitor normally goes to the wiper of the volume control. What I do is I insert the 0.1 100 nanofarad coupling capacitor in here, solder this lead, then bend the lead on this end of the capacitor and take and fold it over to this pin, cut it just a little so it overlaps, and then solder it. So I've effectively taken this lead and soldered it to the base. That makes it simple. Because I'm trying to save time here, I didn't do a video because it requires a little time to set up. But the thing is not as loud as I would like, and I need to check something. I bought 840 transistors, and I used the 3904s out of there. I checked them with my little component checker here, and they showed eighths of FE of 462. All three of them had the same. So that's necessary but not sufficient that they are really good transistors. So I need to check the rest of the group because I don't know if I've got a problem with the board, cold solder joint. I doubt it. If you look at my solder, you'll see the little, I put enough solder on the other side, enough heat that I get both sides of the board well, so there's no cold solder joints here. Well, but I'm going to check this. Now, in order to check transistors, you're going to need a crystal checker for the crystals. So let's go ahead and build one. I got to go off here in the lab and build this. This is from Experimental Methods in RF Design by Wes Hayward et al. Chapter 1, page, whatever this is, page 17, page 11. Figure 115. This is just a simple crystal oscillator. We're going to build it Manhattan style. For those of you who are new, this is a simple project. Doesn't require many components. A couple of 100s, a 3.3, a 10K, and a 10K for resistors. Two 390 picofarad. I use monolith capacitor here. Put a socket here for crystals, and I'm going to put a socket in here for the transistor. I can use this as a transistor checker. I'll see how, with these two component leads, how high a frequency I can put in here and get an output. So let me tell you, I'm going to use this little simple device for three things. One, checking crystals. Two, checking transistors. And I can also, if you don't have a frequency counter, or if you have a frequency counter, you can use this for matching crystals for the IF. We'll discuss that in detail. If you do not have a frequency counter, but you have a general coverage receiver, you can use this simple circuit for matching crystals. You just have to have a good ear for tones. I'll do a demo when we get to it. All right, let me get off to the lab, do this, check it, then we'll get on with the build.